Back to our video questions. if you could please turn to page the next one, which is known as page 494.
Are we going to do number 7?
Does it look like I'm doing number 7 right now?
Number 9. What's the date?
Number 9, 420.
Yes!
The answer's A.
Hold on, Josh. Thanks for the info. We want to see which slope field this is. To analyze this, Josh, first I'm going to look at the change in x values.
Yes.
Josh, does the slope change if the x value
No, it
changes?
does not.
So I can eliminate anything that has an x in it.
Didn't we go over this yesterday?
You may have individually with me, but not as a group.
Oh yeah, I did this. No, we did something very similar on the board then.
Right, you may have done it in your group, but every group didn't do
No,
it.
I swear we did this.
Two days ago we
Hold
did
on,
it
hold on. We may have gone over a couple of these problems. It's okay to see them again.
We did.
Take a look here. What happens to the y value?
I mean,
They
it's not the exact
changed.
one, so it's looking at different
As
things.
y gets bigger, what happens to the slope?
It gets increased or decreased.
It decreases. So the correct answer here is 5y. Now, have you done problems 10 through 12? Because those are the next ones we're going to do. Excellent.
Oh.
Excellent.
I did.
This is my favorite expo marker, by the way.
Alright.
Okay, so I need my chart of information. Where to go? Let me go back to this picture right here for a second. Scroll down to the bottom. The graph below shows the velocity. Shows the velocity of the moving object along this line from 0 to 9. So this graph is velocity, so the values of this graph are velocity. Josh, what is the velocity of this graph at time 2? It's in front of you. You can look right in front of you. Josh,
Yes.
what's the velocity of this graph at time 2?
The velocity of the graph at time 2 might be 2.
Good, because the values of this graph are velocity.
I don't know, it could be.
Acceleration. I wrote velocity. Who wrote that?
What?
It's right. It's not
You're
wrong.
flustered.
These values. Acceleration is going to be the slopes of the graph. So Peter, at time, that's an S. Peter, at time 1, is the acceleration positive or negative?
Positive.
He's right, because the slope of the graph
He's so smart.
is that right there.
Oh, thank you, Josh.
And when we go up, displacement
Oh, God.
is going to be the integral of the graph. It's going to be the integral of the graph. So the area under the graph is going to be my displacement. So Josh, as the graph starts,
Yes.
the area is positive, so it means I'm going farther and farther and farther away. Farther and farther and farther away. Until time 6.
Then you come back.
Then it starts to
Take it back.
go back. It goes
Wait,
backwards.
Is that DI equals?
Displacement equals, or displacement is integral. I'm going to erase this for a second. Oh, not quite an erase. Oh,
I don't think you need to resend the page to erase.
there we go. So that gives me displacement, but what if I wanted total distance?
You take the displacement
Start
minus the distance. The positive displacement minus the negative displacement.
Even easier than that, if I make all of this positive, if I make all this positive integrated, it's going to give me all the distance. It's not going to subtract negative distance or add that.
I meant to say add.
Total distance is the integral of the absolute value of V. I may not need that info for this problem, but so many problems are based on DIVA, so we're going to keep that there. Let's look at the next part. Once again, my favorite marker. 10. At what time does the object attain maximum acceleration? So according to our picture, our graph, what represents acceleration on this graph?
Slow.
Slope. So I want where it has the maximum slope. So which line is the slopiest line?
5 to 7.
Wait.
Or 5 to 8. That
Yeah,
was 8.
5 to 8?
Yeah. Ish.
That looks pretty slopey to me.
No, I think 8 to 9.
I think 8 to 9 looks a tad on the slopier side.
Why?
Alright, I'll
It's like
agree.
the black
I will
Steeper.
agree.
But it doesn't have to be steeper down. It has to be steeper up or steeper down. It looks just a little bit steeper.
Oh, I
Yeah.
get it.
Steeper than the other one. So we're going to circle. Yep. Wait. We are going to circle choice 8 to 9.
So yeah, if they're asking about time, you wouldn't really want B or C, right? Because it's between a time.
Correct.
But when you're looking for acceleration.
Yep.
What ones would just be equal, like those B and C are? Like what would you be looking for? Maybe displacement or something? Wait, no.
It-
Value?
What happened is, if you mistakenly look for the value on the graph, you would pick one of those 2 points.
Yeah, so values are equal, but then the time would really be between
Correct.
numbers.
Number 11 says the object is farthest from the starting point. Do I want to look at displacement, velocity, or acceleration? Yep, the object is farthest from the starting point. What's going to give me my info? Displacement, velocity, or acceleration?
Displacement.
Displacement, and once again, displacement on the graph is the area under the curve. So I'm going to start thinking of eating pieces of area. If I'm eating positive area, I'm walking farther away. I'm still eating positive area, I'm walking farther away, I'm walking farther away, I'm still walking farther away, I'm just going slower. Still walking farther away. When do I start turning around? At 6. So 6 is going to be when I'm absolutely the farthest away. Just because that graph is getting smaller, remember this velocity, it still means I'm moving, in this region I'm still moving forward, I'm just moving forward really slowly, and then I stop. So the correct answer for here is marker, which would be, was that 6? I can't see it on my, I can see it on my picture right here.
Yeah.
6.
Turn around.
Turn around. At t equals 8, the object was at position 10. I'm going to flip the page here. At t equals 8, the object was at position 10. At t equals 5, what's the object's position? So if I want to find its position, am I going to deal with displacement, velocity, or acceleration? If I want to know its position, am I going to do it with displacement, velocity, or acceleration?
Displacement.
I agree. They want displacement at what time? 5. Well, I know at 5 to 8, I can tell my path that I walked. I actually walked this little triangle, which the area of which is 1. And then I actually started walking backwards, and the area of this is -4. 1/2 base times height.
Wait, but why didn't you go all the way to 9?
I didn't. I went to 8. Because they asked me. They asked me they told me at 8 where I was. So they gave me a piece of info. And now I know how far I've walked. I've gone, this was -4. So between 5 and 8, I've taken -3, I've moved -3 places. So where was I at time t equals 5? And the question is, I know I moved 3 places. Was I at 13 or was I at 7? It's one or the other. I always mess it up, so I added and subtracted both on. So let's start with 7. Let's say 7. Let's write down 7. If I start at 7 and then go backwards 3, where do I end up? Do I end up at 10? No. So I'm going to go and I'm going to write down 13. If I start at 13 and go back 3, where do I end up? 10. So the graph always gives you the number you need, but you got to be careful that you put it in the right way. And the reason I have it in is they had us walking back. They gave us an end time way to figure out where we started. And I haven't looked yet, but I bet you that 7 is a choice.
Yeah, it is.
There's my marker again.
Wait, I don't understand how you got 13.
It's called addition.
Would you agree, Em, that
Wait, you just said 7 is a choice?
I'm going to erase this. Oh, I'm going to erase this for a second. So anyway, they told me that when I ended at time 8, I ended up at location 10. At time 8, I ended at location 10. So how far did I travel between 5 and 8? That'd be the area under the curve. I computed that rectangle was 1. I computed that rectangle is -4. Okay? So what total distance did I go in that time frame? I went negative 3. So the question is, where was I at T5 then? I'm either going to add 3 on or subtract 3 on. I'm never really sure until I talk the problem out. So let's say I wrote down 7. If I start at 7 and go backwards 3 units, do I end up at 10? No, so it wasn't that. So this time I'm going to add 3 on to 10, and then let's say it's 13. If I start at 13 and I walk backwards 3 units, where do I end up? 10. So it's always easy to find the number. You just have to test it to make sure you're putting it in the right way. So my correct answer would be marker. It would be 13. 13.